Hello, happy 2020. Alright, this is our first video of the new year, so we're going to go ahead and get down to business. I've even painted my nails for you guys, the nice winter white, and no, I did not use whiteout. It actually is nail polish. But anyways, I'm going to go ahead and get started so I don't take too much of your time. We're going to jump in with our new unit on probability. So remember, at any time during these lessons, if you want to pause and stop to catch up on something you missed because I'm going too fast, please do that. That's the beauty of the flipped classroom. You can stop it, you can rewind it, you can watch it again, you can watch it 100 times. It doesn't matter. You need to tailor it for what's best for you. We're all different learners. We all learn at different paces. So that's the really awesome thing about this structure. So probability. We're going to do some definitions right quick. Okay. So what we're going to do here is we're going to draw a chart. So draw just a chart with 4 quadrants. Okay. And the first quadrant is going to have the definition. Okay, definition. The second quadrant is going to be what's called a tree diagram. You're going to see what that is. Then we're going to have the theoretical probability and experimental probability. So go ahead and pause this if you need to. Pause this, and you can go ahead and catch up. All right, so let's go ahead and get down to business. The definition of probability. What is probability? Well, you guys finished this at the last time you saw probability was the end of your 6th grade year. It was something you probably did at the end of the year, maybe before your test, but most of you did not see it. If you didn't see it at all, you might have seen it here in advanced math, but if not, then you may not have seen it, but it's not super hard. Okay, so probability is the extent to which an event is, and I'm going to write this in a different color. It's kind of a keyword. Is likely to occur. It's measured by a ratio of the favorable total, the favorable cases to the total number of cases. Okay, so all the probability is where it's the extent to which an event is likely to occur measured by the ratio. So you're going to see some ratios in probability. Ratios look like fractions. Of the favorable causes to the total number of causes. Okay, so I will draw an example. Okay, so if I were to say, what's the probability that when you roll a die, that the number will be odd? Well, we know in a die there are 6 sides. They have 1 through 6. So out of those 6 numbers, 1 through 6, how many of those numbers are odd numbers? Well, half of them. So that would be 3 of them are odd. The total number, the favorable cases is 3 of them. The 3 of them would be odd. That's what it's asking us. And 6 would be the total number of cases. So 3 over 6, you're going to reduce that to 1 over 2. So the probability would be 1 half. Okay? All right. Let's keep moving. Tree diagram. Tree diagram. Some new pins. So, I'm going to... Has nothing really to do with a tree like this, but it does kind of look like a tree. A tree diagram is just a diagram that shows the total amount of, let me go back to some keywords here, possible outcomes. Okay, so heads versus tails, all right? Flipping a coin. And you say, what is the probability that it will land on heads? Okay, so you do a tree diagram, you would start out with heads, and then you would have tails, right? Those are your two different options, right? This is an example here. So, you could have heads or tails. Let's say you flip it 10 times. 10 times. The probability could be heads all 10 times, or tails all 10 times. Probably very unlikely, right? Or you could get a mixture. You could get, you can make a tree diagram. You could do it vertically or horizontally. It could be heads, tails, heads, and then heads, or heads and tails. And then after that, it could be heads or tails. And then it could be heads or tails. And you just keep making the branches. Okay, and then that, it's just, that's why we call it a tree, because it's like you go from one branch to another. So it could be like this, or it could be, this is a vertical tree diagram. It could also be a horizontal tree diagram where you start out like H would be here, and then you'd have TH, TH, like that. Alright, so you would map it out as you would flip the coin. That's a tree diagram with the possible outcomes. Alright, so we'll be doing a lot more of those, so don't get bogged down if that was not an example that you really understood right now. We'll be doing some more in class. Theoretical. That's a very big word. Don't get scared by it, okay? Theoretical just means, I'm going to put this in parentheses because it's going to be part of your fraction. Number of favorable outcomes okay, divided by the total number of outcomes. So theoretical is you're not really doing the experiment yourself. You're just saying that this would have been a theoretical probability, the dice. We know that there's 3 odd numbers on a dice out of 6. So 3 favorable outcomes out of 6 would be the odd, if it's asking about odd. 3 out of 6 is just 1 over 2. We're not actually doing an experiment to test it. Okay, we're just saying, based on what we know, there are 3 odd numbers on a dice out of 6 total numbers. So 3 out of 6 is 1 over 2. And that's theoretical. You do not actually do the experiment. Don't actually perform experiment. Experiment. Oh gosh, my brain is working too fast. Okay. You don't actually perform the experiment. Okay? Now, look over here. On the other hand, the other kind of probability is called experimental probability. Do you think we're going to actually do an experiment to get this answer? You betcha. Okay? So experimental probability, you end up with a ratio answer, just like you do in theoretical, but it's the number of times an event occurs, like you actually do it. You actually do the experiment. Let's stretch that out a little bit. Over the total number of trials. Okay? So this is where you actually test it out. So theoretically, you have a 1 out of 2 chance of having rolling a odd number on a die. Well, experimentally, if we actually did roll the die 6 times, we could have, and let's say we landed on odd only twice. That would be 2 out of 6. That's only a 1/3. We would have a different probability if we actually test it out. Okay? So, key here is that theoretical is probability based on reasoning. Reasoning, just theoretical. Like, here's what we know. This is what we think. It's just on a reasonable answer. Okay? But experimental is probability based on an experiment. Okay, so we will be looking at this more in depth in class this whole week. We are going to be taking this step by step, and we're going to be looking at simple and complex experimental and simple and complex experimental probability and simple and complex theoretical probability for the next week and a half. Okay, that's what this whole unit is over, is probability. So you're going to be probability masters. Now I do want to give you a few more definitions for things that you're going to see tomorrow on your worksheet you'll do in class. I'm going to draw another line to kind of divide this up. Okay. Tomorrow in class they're going to give you cases, scenarios where you're going to determine the probability of each event. You're going to write either impossible, unlikely, as likely as not, likely, or certain. Okay? So let's look at that. Impossible in probability. Impossible is a 0% chance. Okay? It will not happen. 0%. Unlikely, that's it's less than or equal to 25% chance. Okay? As likely as not, that's a 50% chance. It's like it could be either likely or not likely. Okay, and I'm going to actually make a change here. I wrote the wrong number. This is not going to be less than or equal to. It's just going to be less than 50%. Anything less than, if your answer is less than 50%, it's an unlikely occurrence. If you factor your probability and it's less than 50%, it's an unlikely probability. If it's 50% chance even, like when we did up here, it's 50%, 1/2. That would be we would say the probability is as likely as not. Okay? So those are, now on the other end of the spectrum, likely is going to be greater than 50% chance. And then certain is 100% chance. Like it's the only opportunity, the only option. It's certain. Like if you only have a bag of orange marbles and it says what is the probability you would pick an orange marble? If orange is the only color you have in there, you have a certain probability you will pick the orange marble. It is a 100% chance because they were all orange. I'm going to color code these. I'm going to put these in the green zone because they're very likely. They're above 50% likely. I'm going to put these in the red zone. They are not likely. And then this one we're going to say is in the yellow zone. And it's 50-50. As likely as not. okay? All right. Have a good night. I'll see you tomorrow.